Hello everyone, welcome to our next tutorial. Today we're going to be looking at the Sentinel toolbox and how we can use it for downloading and visualizing satellite imagery. My name is Shaun Levick from the Geospatial Ecology and Remote Sensing Lab. I'm going to be running this tutorial on my Mac, but the great thing about the Snap toolbox is that it's multi-platform. So you can run this either on Windows, Linux, or Mac. And I'm just going to make it full screen. This is the Snap environment. Snap is produced by the ESA, that's the European Space Agency. So we'll start by saying a big thanks to the ESA for not only producing the satellites which provide us with such great data, but also for funding and providing a toolbox to analyze those data streams. This program is free software. You can redistribute it and or modify it under the terms of the general public license as published by the Free Software Foundation. Now we've installed the full Snap version, which means we have the Sentinel-1 toolbox for analyzing Sentinel-1 radar imagery, Sentinel-2 toolbox for analyzing multi-spectral imagery, Sentinel-3 SMOS, RadarSat, and also ProbaV. Now, the tools from these different toolboxes are embedded within the menus, so we won't be using the toolboxes individually, but just be drawing on the different tools as we need them. For today, we're going to be focusing on Sentinel-2 data, which you might be familiar already with Landsat type imagery, multi-spectral, medium to high resolution imagery. Sentinel-2 is more recent and has a very high spatial resolution with great multi-spectral wavelengths as well. So if we want to be able to find and download some Sentinel imagery, we don't have to leave the Snap environment. Over on the right hand side is the product library. We open that up, we see this interface with the little world map. You can zoom in to an area of interest down in the bottom here. You can use the right click to pan the map back and forth. Use the scroll wheel on your mouse to zoom in and out. Let's navigate up to the top, orientate ourselves. For those of you watching from elsewhere in the world, we're based in Darwin, which is up here. For today's exercise, I'm going to zoom in to an area right up in the Northern Territory, world famous Kakadu National Park. I'm going to draw a little box, small box, roughly in our area of interest. So what this does is define our spatial area of interest. Now, if we have existing data on our computer, we can find it within the product library. But if we're looking for new data, we can access the ESA Science Hub. And you'll see that that'll bring up options of their different missions, and we can easily access Sentinel-1, Sentinel-2, and Sentinel-3 data from this interface. For today, we're interested in Sentinel-2, and we're going to be looking at the level 1C data. Importantly, a few more things. If we know specifically the products we're looking for, we can type in the names, acquisition modes, and passes. If we know the track number, we can limit our search by using these variables. For today, let's start by searching for imagery over the course of 1 year. So we'll search from 1st of January 2017 to December 31, 2017. And a few other things we can include is the percentage cloud cover that we're willing to accept. Obviously, in most situations, we'd prefer to have no cloud. Working up in the tropics, that's not possible, except in the very middle of the dry season. So let's put in a limited range. Let's go 0 to 5% cloud cover, and let's hit the search button. That can be found up here. I must just mention that you may be prompted for a username and password. You do need to register an account with the Sci-Hub from the ESA so that you can access the data through this interface. There's no cost to having an account. It's merely just registering username and password with the European Space Agency's Sci-Hub. Now, we immediately get some information. Down here in the status bar, we can see retrieving entry information, 39 entries. And this little status bar shows us our progress. What that means is that they've searched the archive for the year of 2017 for images with less than 5% cloud cover, and there are 39 scenes that intersect our little box. And depending on how many entries you find, it can take a while to download. You can keep an eye on the status bar down there. This workspace here will then be populated with the different images, and you can navigate through, select the ones most appropriate, and download them. For now, we won't wait for that to complete. I've downloaded a set of images already, which you can find in our Sentinel-2 folder. And let's have a look at the file names. Very long file names. First part telling us Sentinel-2, that's the S2. We have S2As and S2Bs, bearing in mind that Sentinel-2 is a constellation, and as such it's actually two satellites which are opposite each other in orbit, allowing for a more frequent revisit time. This tells us that it's a multi-spectral imager, and we're dealing with level 1C data. Means it's already useful for us. It's not a completely raw product. What can sometimes be confusing is that there's two dates in the file name. You can recognize this 2017 05/12, so year, month, and day. And looking across over here, 2017 05/12. This is pretty consistent throughout, that the dates match. They might not always match. The first date is the date that the image was actually acquired, and the second date is the date that it was ingested into the archive. So there can sometimes be a difference in that. We'll primarily always be interested in the acquisition date. So if we sort here, we have a number of different images obtained. Let's see, November, got 2 in August, 1 in October, 1 in September, 1 in June, and 1 in May. So I've selected a range of images throughout the year. Let's open up the first scene, the earliest scene. So that's from 12th of May 2017, and you'll see that these are zipped folders. You can unzip them and open the XML file, but Snap does support just opening the zip, and it can read the contents of the zipped file. It's quite a nice way of transferring these. We click on this little downward arrow. This might look slightly different on Windows machines, but in general the structure is very consistent across different operating systems. Clicking on this little downward arrow, we have 4 folders: metadata, vector data, bands, and masks. Let's open up the bands folder, and you'll see that this Sentinel-2 image, like all Sentinel-2 images, are comprised of 13 bands. You'll see they first it looks like there's only 12, but remember that we have 2 bands in band 8. There's band 8 and band 8A in a very similar wavelength. So we range from 443 nanometers through to 2190. Now, if we were to open, well, we can open up each of these individually, which we'll do in a moment. But usually what we want to do when we first open up an image is have a look at a true color RGB composite. And we can do that just by right clicking on the file name, and you'll see we have quite a few options pop up. So just bear in mind when navigating Snap, familiarize yourselves with all the options under these different headings up here, but a lot can be done in context. So right clicking the file gives us the option of opening an RGB image window. So let's do that, and what's quite nice is we have a number of profiles automatically built in. Here we have a profile preloaded, Sentinel-2, multi-spectral imager, and natural colors. Remember that for a natural color composite, that's very similar to what our eye would see, as if we're looking out of an aeroplane at the landscape. And this is a true color matching. We're putting band 4, 665 nanometers into the red channel, band 3, 560 into the green channel, band 2, 490 into the blue channel. So let's open that up. Remember that Sentinel-2 data is at 10 meters resolution in the visible range, so quite big images. Take a little while to open the whole scene, and there we have it. Beautiful images, some lovely differentiation in the ocean there. We have quite a brown looking landscape, a few clouds, hard to avoid clouds in the tropics. We can zoom in using the scroll wheel on the mouse. We also have a zoom tool up here, as well as a hand for panning, moving around the image. Coming down to the left here, we have a navigation panel. If you click on that, we can use this also as a way of navigating. This is our keeping context of where we are in the image. So if we zoom in a bit closer, what's quite nice, if we use these magnifying glasses, the one with an A takes us to the full area of the image. The one with the P brings us into the pixel level, so the highest resolution of that image. We can grab that little box and move it around and use that to explore the image in higher detail, and we can see some very nice patterns. It's an amazing landscape, Kakadu National Park, Northern Australia. While we're having a look around here, let's just see what other options we have. Open an RGB image window. Let's do that again. But now we have a couple of other options. So if we use this one, false color infrared, we've now put band 8, which is the infrared band, into the red channel, band 4 into the green, and band 3 into the blue. So what we've done is we're making a false color infrared composite. Let's click OK. And this view will be heavily optimized towards exploring photosynthetically active vegetation. And that's why we see so much red in the resulting image. Red here being green vegetation in reality, so absorbing and reflecting light differently. Let's zoom in a bit closer here. Have a look at some of these areas alongside the rivers. We see a lot of green. We see a lot of very interesting spatial patterns in this landscape. Let's come right up to the edge. Possibly some mangrove fringes and some riparian vegetation with savanna woodland in the upland areas. Now, while it's great to be able to do that, what's very interesting is to be able to view both the infrared and the true color at the same time. So at the moment we have these in two tabs up here, and we can flick back and forth between them. But a more elegant way is to tile the images either horizontally or vertically. I'm going to tile them vertically for now, and make sure that you've ticked on these two little icons here. This one, the bottom one, synchronizes cursor positions across multiple image windows, and this one will synchronize the views across multiple image windows. And what that means now is that both the upper and lower image are showing exactly the same area, and that I can move through them at the same time. So a nice way to navigate is just to grab this little window in the bottom left-hand corner, and as you move that slowly around, we see the same image in false color infrared and in natural color. And that's a very nice way of exploring these differences in how light is absorbed and reflected in different wavelengths. What I'm going to do now is close these two scenes, and I'd like to look at a few features in isolation. So for instance, let's start by bringing up band 2, open image window. Here we have it. Let's open band 4. Let's go to band 5. And band 8. So now you can see we've got these 4 images open, moving from a narrower wavelength, stepping through to longer wavelengths. And it becomes increasingly apparent that as we move from the shorter wavelength, we see a lot of detail in the ocean, and the land is very dark. That means a lot of absorption over land, a lot of reflection over the ocean. As we come through to the longer wavelengths, moving into the near infrared, we see the ocean becoming almost completely black, meaning that the infrared wavelength is almost entirely absorbed by water, but we see the much brighter coloration over the land because vegetation is strongly reflecting the near infrared. So a nice way to look at this is to go back to our windows and say tile evenly, and let's zoom out to the full extents. Now we have these 4 images on our screen, and we can see this nice transition moving from the very short wavelengths, sort of the blue lights, through the greens, reds, into the near infrared. So I'd like you to take a few minutes to explore some of these different bands. You can close the windows we have open and have a look at some of these different combinations. Remember that as we get further along the wavelengths to the longer wavelengths, we move into the shortwave infrared, and that some of these bands will have a slightly coarser spatial resolution, but are sampling much longer wavelengths. And I'm just opening up here the first band in the shortwave infrared. You can see the substantially higher than the visible, and you can see how pure black the ocean and the rivers are, as it's completely absorbed by water, nothing reflected back. You can also experiment a bit with different RGB visualizations. So if we were to open this up and try a new combination, let's say we wanted to bring in that shortwave infrared into our RGB composite and make something like this using bands from the shortwave, infrared, the near infrared, and the visible. We'll see we get a little warning here: referenced rasters are not of the same size. Now that's because the raster resolution is not constant across the wavelengths, and our visible bands are all at 10 meters resolution, but the shortwave and some of the red edge bands are at 20 meter resolution. So if we click OK, it's going to give us a little error saying that the image can't be created because we're trying to mix bands with different resolutions. So what we need to do is head up to raster, geometric operations, resampling. And what we'll do is just resample those 20 meter resolution bands down to the, or up to the 10 meter resolution of the visible bands. So this is a pretty consistent interface for Snap. You have your input and output parameter tab, and then your actual action tabs over here. So let's go input output. The name of the product is the one we have already selected. Our target product is automatically named just with resampled on the end. We'll leave that for now. Resampling parameters. Define size of resampled product. So what it allows you to do here is to either define the pixel size, the spatial resolution, by a band from the source product, or by specifying the width and height of the image, or by specifying the pixel resolution. If we come up to reference band and change that to band 2, it's now one of the bands in the visible spectrum. We know that's at 10 meters. We have a variety of different sampling methods. We're just going to use the defaults for now. So just be sure that that's band 2, and we'll say run. Now something that Snap will do is inform you that the target product has successfully been created and opened in Snap, but actual processing of source to target data will only be performed on demand. For example, if the target product is saved when image view is opened. So that means it's putting it on the to-do list, but it's only actually going to do it when you really need it. So you can just say OK. And we see that that resampled image has been added over here, so we can say close. Now let's just quickly look again at our RGB options for this first image. So when we say open RGB and we go on the profiles, you see we only have these 3 options: natural colors, false color, atmospheric penetration. Let's have a look at the new image we've just created. Open RGB image window, and let's click on these profiles, and you'll see suddenly we have a lot more options. That's because we've resampled all of the bands to that 10 meter resolution. We now have more combinations that we can play with. So let's go to this shortwave infrared composite. That's the one we tried to do earlier, band 12, 8, and 4. Let's say OK, and now that opens up nicely for us, allowing us to incorporate the shortwave infrared, that much longer wavelength, into our image and our analyses. Play around a bit, spend a bit of time having a look through all these different options. You'll see some are dedicated towards urban detection features, agriculture, healthy vegetation, separation of land and water, natural look with atmospheric removal. If we take one of the healthy vegetation option, we'll see we've got red, we've got band 8 in the red channel. We're pulling in that shortwave again into the green and then keeping blue in the blue. Let's just have a look at that one. This one really highlights differences in vegetation. So actually let's close other one, leave healthy vegetation open, and let's open up the false color infrared that we had earlier. So that's sort of the more sort of quick way of looking at photosynthetically active vegetation. If we tile this horizontally, let's rather go for a vertical tile and zoom in to that little island again. And what I want to just show you here is that if we're only using the near infrared, so this false color infrared is using the near infrared and the red, and it shows us photosynthetically active vegetation. But having a look at this lower image, as we zoom in here and bring that up, you can see that we've got much more detail in the vegetation. We can start distinguishing. If we look at this top image, we wouldn't think that there's much difference between the vegetation, say over here on the left hand side to over here. But when you bring in that shortwave infrared, it really helps you see more subtle differences in the vegetation. And that's also true as we move through the rest of this image. So that's all I wanted to get to for this first tutorial on band combinations. In the next one, we're going to look more closely at spectral responses by investigating spectral response curves. So thanks for your attention, and I hope you found that useful. And before we end, just one more thing, almost forgot. If we head back to our product library up in the top right corner, you can see that this has now been populated with a whole range of images that intersected that little window that we drew earlier. And what's great is down here on the bottom is a little timeline. You can see when these images were collected, so throughout the year. And just scrolling down here, you can click on a particular image. You get a little scroll window that pops up, and you can see what that looks like. Quite important is to keep in mind the file size. So each of these full scenes is about 700 megabytes. And once we click some of these, we have the option then of, if you highlight it, you have the option then of downloading it. So that's all for today. And as I say, we'll be following up. A new video will be posted each week. Hope that was useful, and see you next time. Cheers.